All right, welcome back, everyone. Hope you enjoyed your lunch. We have an interesting session coming up here back in the blue room. We have Simon, Steffen, and Mark, all from the CAP team, talk about data products today. So without further ado, give them a warm welcome, big round of applause. Off you go.
Right, again, welcome to our session on CAP apps and data products. For the agenda, I give a little introduction, then Mark will talk about cup-to-cup integration via replication on demand, and then Simon will talk about integrating data products. Just right in the beginning, a short disclaimer. So the title and the abstract of the session was very specific towards data products, but in the meantime, we have shifted or broadened the focus a little bit and start to talk a little bit, not only about data products, but about data integration in CAP in general. We have two examples for that, one with Mark, one with Simon. And before we start with the demos, I just give a little bit introduction. And this is about how can data be moved, say, from one CAP application to another one. It's always the same picture. We have one CAP application that works as a data provider. We have another CAP application or CAP microservice that wants to consume the data of the data provider. How does it work? Always the same story. It's like you as a developer or the developer of the respective applications in the provider, you just model a service which serves as an interface for the data that you want to make available for others. It's a regular CAP service with entities. Usually there are projections on some more basic entities, which are the tables in your application. And then, as Daniel has showed in his keynote this morning, there is something like a CDS export where you can then narrow down and produce a snippet, season snippet or whatever, that is exactly only this service interface. Then you can move that out of your application, publish that. This can be as simple as a season snippet, but we encourage to make it a bit more nice for the consumers to define something which is something like a pre-built integration package. So not only a season snippet, but nice CDS files, which maybe are also commented. You can add test data for the entities that you are shipping. You have maybe I18N files with some nice texts. And then you put this together as a package, which then can just be required by the consuming application. And the consumer can simply import that. It's then just another package like which you can maybe just install with npm install. And then you have that as a part of your local model, and you can just use it as if it was a regular part of your model. You can just put projections on it, views on it. You can use it in model, can use it in your custom code, can maybe put Fiori UIs on top of it, or even doing some embedded analytics that means defining a analytic model. What happens behind the scene should not be too much of relevance for the ones who are doing the publication and the consuming of the service. So in general, for the actual plumbing, there are several strategies which you maybe only choose later or can even change at some point in time. What we have or what we are working on is, first of all, replication on demand. This is what Mark will talk about in a few minutes. But if you have two CAP services which are running on HANA, you can also think about plumbing or connecting the basic entities which are behind the service interface via virtual tables, or if your microservices are on the same HANA instance, you can do it via synonyms. And when I say you can do it, it means actually you as a developer should not be concerned with how are the details of the plumbing. This should be done by the framework for you behind the scenes. So for you, it should only be something like maybe changing some configuration, and then everything that is needed to do the plumbing should happen in the background. I say should because this is something which is not yet available, so you cannot go home and test it right away, but this is something we are currently working on. A benefit of this approach is that you have a decoupling of the consumer and the provider. That means if you have imported your model, you can immediately do some local testing. Yeah, you can run your application without being connected to the data provider. You can continue developing and just mock the provider, and only later do the actual plumbing. That means you can also, independent from each other, develop further the provider and the consumer. Now, this was CAP to CAP. Yeah? CAP is a data provider and the CAP microservice as a consumer. But this picture works also if not both sides are CAP. So the same concept can only and is also applied if the data provider or the data consumer are not CAP. For example, if a CAP application should consume a data product, it's basically the same picture. In that case, the data provider is not a CAP application, but is SAP Business Data Cloud. But again, the data itself is described essentially as a season, which can be then imported by the consuming app, and then the consuming app doesn't care whether the data comes from a data product or from another CAP application. It's just a service, a regular season service. And behind the scenes, the data essentially is then accessed from BDC via virtual tables. This is what Simon will show later. The other way around, if you have a CAP application that is going to provide data for a data product, it's just the other way around. Now the data, the application that contains the data is a CAP application. Again, you define your data product as a service, as a regular CAP service with some entities which are projections, and then you export that. And then again, you export it as a season, and then this season is kind of shipped towards BDC and then turns into a data product. And then the data replication, again, should not be of concern to you. That should happen behind the scenes, that some HANA mechanisms are used to replicate the data from your table or view into BDC. Right, with that as a forward and introduction, I now hand over to Mark to show you the first part, now CAP to CAP data integration with OData.
Thank you, Steffen. So let me switch to our editor and let me introduce you to our sample application or our demo application that we will use now throughout the further session to show you the data integration via OData as well as the data integration via Business Data Cloud data products. So here we have first take a look at our provider application. So the application that provides the data in our scenario. We have here a simple service. It's the business partner service. It serves various entities here, customer entities. It's actually the customer API that's also available in S4. You can also take a look at the domain model. So you see it's a huge customer entity. If you're maybe familiar with the S4 API, you might recognize some fields. But this is just a scenario that we are working here now with, and we also have some further information in the CDS. For example, we have events defined here. So also next to our synchronous APIs, we can also define asynchronous APIs. So maybe the service publishes events when customers are changed. And we also have some annotations here. So we want to now make it very easy for our consumers to connect to that API. And as Steffen said, that involves publishing a season that the consumers can import. And ideally, we do that in an integration package. And this is what we will now prepare. We will prepare a client library that will make it easy for the consuming application to connect to this API. Maybe if you're already familiar with our remote OData features, then you've seen in the past that we usually do this in a way that to connect to an external remote OData API, we first import the IDEMX, which is the OData specific specification of that API. We, for example, download it from API Hub in case of an S4 API, and then we have the CDS import command to create the CDS out of that to work with in our local application. However, here we are now talking about CAP-to-CAP application integration. And wouldn't it be nice if we could just use the season from the provider application directly in the consuming application? So without going via the IDEMX export and import, because the IDEMX export import is actually not lossless. It loses information. For example, we can't capture things like the asynchronous APIs, like the events in there, and we also lose some annotations. So let's maybe take a look at the season that is in the end, the whole model of the providing application. Because actually that season directly is not really suited for import in a consuming application. We have a lot of implementation details here. For example, we see all the business partner service entities are part of that season, but we also see all the domain entities that are defined on the database level for the provider application. And if we look into the details of that customer, for example, we also see here that this is actually defined as a projection on these domain entities. And when we, in our consuming application, we are not interested in all of these details because we just want to care about the API surface. And for that, we are now working on a new command that Daniel already teased in his keynote, which is the CDS export command. This enables the providing application to export an API for consumption in a consuming application, and does have a better way of exporting than going via the EDMX approach. So let's take a look maybe quickly at that command. What are we doing here? We want to now export our business partner service from our provider season. We also tell the CDS export command to keep the associations. This means that all information about associations, like on conditions, are retained. This makes it also very easy to use that generated season for local mocking in the application, in the consuming application. Here in our case, we are dealing with Java, CAP Java applications, so we want to export that for a Maven dependency. You could also export it as a node module, as an NPM dependency, and we also give like the coordinates under which that Maven dependency should then be available in the consuming application. So let's run this command. And we see that it did two things. First of all, it created a services season and also an I18N JSON. So let's take a look at the services season first. And now you see that actually this is a little bit different. Now in that season, we only have the business partner service included, no longer the domain entities. And if we also look at the customer, we do no longer see the projection. So all of these implementation details are gone. However, things like the event here, for example, the customer changed event, are retained in that season. And it's also externalized. So we have added some annotations to mark these entities as external entities, so that we can distinguish them also from the domain model and the services of the consuming application. And with that, we have basically generated this now, as you can see here, into our client library package. So this is basically a separate Maven dependency, or could be a separate node module, NPM dependency that we can publish to Maven Central or some internal Artifactory or to npm, js.org or whatever. And that consumers can now use. And the advantage of having such a library is that you can add also additional content into that library, not only the season snippet, which would already be sufficient for a very simple integration, but we can also add further data to that library. And one of those things you've already seen here being generated, for example, the CDS export command also exports all the labels for internationalization that are defined by the providing application, so that they can be reused also in the consuming application. We can also add data, like Stefan already mentioned, for local testing. And we can also add predefined configuration. For example, here we add CAP Java related configuration to pre-configure the business partner service as a remote service and connect to a locally running version, for example, of it. But we can also provide default properties to be used in the cloud with destination names and stuff like that. And of course, because it's a Maven dependency or NPM module, we can also put code into this. So we can also deliver logic together with that. And we will see that in action also in a second. So with that, we have a nice integration package that consuming applications can now refer to. So now let's switch gears to our consumer application. This is the model of our domain model of our consuming application. We have here a very simple scenario. Basically, the idea here is that our reCAP staff wants to be able to maintain orders of the great reCAP merchandise that we had in the last few years. So we want to allow them to record orders, and we want to be able to also capture the customer, the buyer that wants to buy a reCAP merchandise, and actually for that only past or current reCAP participants are eligible, and we get this information, of course, from the customer API, because we manage our reCAP attendees with an S4 system. And for that, we now need to extend basically here our orders entity with an association to that external customer entity. So first, what do we have to do? Okay, we now want to use that client package. We integrate it into our POM XML here for Maven. We define that as a dependency. And now with that, we can actually now start using it in our models. So we can now refer to that external definition, the business partner service, with the coordinates that we also saw in the CDS export command earlier. And the first thing that you should always do if you import APIs is you should define what we call a consumption view on top of these imported APIs that tailors the data to the needs of your application. So here in our scenario, we don't actually want to import the whole customer API with its, 50 elements or so. For our use case here, we are basically just interested in two: the key, the customer, and the customer name, because we want to be able to show the name on our UI. So very simplified scenario. You can, of course, add more, but here we just are interested in those two. And we also don't like the names, too much customer in here, so let's just rename it to ID and name. And what we also do is we mark it as auto-exposed. So for our Fiori UIs, these entities are available out of the box for value helps. And we also want to be able to replicate the data and store it locally. That makes it also easy to serve a UI on top of that, because we can just push down all the expands that, for example, Fiori sends directly down to our database when we have replicated that data into our application. And that's why we also create a table for that consumption view. And then we extend our orders domain entity now with this new association to the entity that we have introduced here. And we also have here this magic replicated annotation. This is actually now triggering this on-demand replication that I will also explain to you in a second. And the logic for that on-demand replication is actually also part of that client library. So that client library brings all of this logic to enable replication in the consuming application. So this is, for example, an example for delivering also code together with this integration package. Let's switch over here to give you an idea of what this replicated annotation does. The idea here is that this is really suited, this on-demand replication is really suited for a master data scenario where you want to refer to some data in another service that you want to serve as a value help in your Fiori application, want to refer to, then maybe show some information on the UI, and maybe also require some data to perform validations in your application. Also here, it comes handy that the data is actually stored in your database. No, I'm still here. Because with that, it also comes handy if you have the data in your database, because then you can use techniques like assert constraint, which is a new feature from CAP to push down validation logic to the database, also on this data that was imported from an external service. And if you want to learn more about that feature, join our session for validation and field control later today. So what does this replicated now actually do? I try to explain why it's useful, but what happens now actually if you put this annotation on an entity is two things. We have first the value help scenario, which is like a simple scenario where the Fiori application just requests all the buyers to show a value help. And that request goes to consuming application, and the client library has some code that automatically then forwards that request directly to the provider application, so that we serve all the data that we have in the provider application to show in the value help. And then usually the user selects one of the values from the value help, and this triggers a patch or post request in Fiori in the end with the foreign key that is set now in our local entity. So our orders entity is now changed or inserted, and we have a foreign key now for the corresponding buyer. And also that is something that this annotation reacts on. And in that case, it detects, oh, I now selected a buyer, and I get that specific customer from the provider API. So here with the same ID, ID4, and I take the data and insert it into my own database together with the foreign key that is set as part of the regular update of the order. And that's where the on-demand aspect comes in, because we only replicate the data that is actually referenced from within our application, but we can still serve all data for selection with the value help. So let me show you that in action as well. So we can now, with all of the configuration that is provided here by this client library, we can now first start the application in a mock mode, where we basically serve our provider API as part of the consumer API. And we use the test data that is delivered as part of the integration package for that. So I've started the application here. Let me switch over to the browser, run it on localhost. We see now that we have the business partner API now served by our consuming application as a mock API, and also our regular orders API, which internally connects to that business partner API. Let's switch to our orders Fiori application, and we can now create an order. Let's just say we want to order something from reCAP 2025, and we can now select a buyer. And here we see some data, and that is actually the data that's coming from the client package. So we have here some mock data. Yeah? So we have Tina test, for example, mock data that we can select here now. Now let's also show you how this, just with a simple configuration switch behind the scenes, we can switch to that sandbox mode, where we are actually connecting to the running provider application, but also just all locally here. So I will also now run the provider service locally in the VS Code. And in addition to that, I will also run the consumer service with a different set of configuration that is also part of the client library. I just set a different profile, and that connects to the consuming application that is running locally. And that can switch back to the UI. I have to create a new order. And if we now look at the buyer information, for example, you see the data has changed. We now have productive data, for example, Peter Productive. And that's now the data that's served by the actual provider application running locally. But all of that happens behind the scenes. I don't have to care about that in my code. It's just configuration, and most of the configuration is part of the client integration package. And with that, I hand over to Simon to show you how the same techniques also apply when using data products.
I think I'm online now. Perfect. Okay, I have a few slides, not a lot, I promise. So I'll talk about consuming data products. First, a few background words on words you've probably heard in the context of data products. One of the big ones is business data cloud. There's the official definition. I'll give you the quick rundown. It's a big box with magic in it, a big HANA data lake, and lots of little data products. The HANA data lake is an important part because that's what we are going to integrate against with our virtual tables. All the magic is not of concern for us at this point in time. What's in a data product? Data. Who would have guessed? Next to the data, there's also metadata that makes them easier configurable or consumable and gives you some context around it. We are mostly interested in data. The context around it is useful for finding the data products. So let's take a closer look inside the data product. I've spent a lot of time on PowerPoint animations. One of the parts we have in there is ORD information, so some open resource discovery magic. We have some HDLFS configuration, HANA Data Lake file system or file storage. Not sure, to be honest, because we need to know where to find data product in our HANA Data Lake. So there's shares, and then there's schemas in them, and in the schema you then have tables. So there's lots of levels to go down. And we have a season, as Stefan already mentioned. This season is very good for us because this season makes it so that we can import the data products and integrate them with CAP, because CAP and season goes hand in hand pretty well. It's an interop season that's not looking exactly like the season that you would see in your CDS compiler, but we can work with it. So it's all good on our side. Now, how does this feel like if you're running on local? I will show code in a second, no worries. On the local machine testing with SQLite, for example, you get your normal view, and then you select from your table. On local, you don't have any connections to a BDC. It feels like a local table in your HANA, in your database. If you are initially deploying to HANA, you get a view with a synonym, and then you get a dummy table. Because obviously, HDI wants every table that is referenced by a view to exist somewhere, but we don't have a connection to the BDC system yet. So what do? We know, okay, at some point in time, your data product is going to be there. Let's just put a synonym there that's called whatever your data product table will be called in the end, and redirect it to a dummy. In this dummy table, you can also insert your CSV data, for example, your HDB table data, so that you at least have something when you get running. And now, when the data product is installed, we are not sure when it will be installed and how it will be installed. It will be installed at some point. We take the synonym, we create a virtual table, and we point the synonym to the virtual table. So this virtual table is actually your data product then, the connection with the BDC. We are using a remote source behind the scenes, and the remote source can then point to the HANA Data Lake file system. So that's how the technology behind it works. I'm going a bit fast because Mark took a bit of time, and we want questions in the end. So let's take a look at what we do on model perspective here. We don't have a nice client lib like Mark showed, but we have our model imported here. Index CDS is just putting the parts together, and this is an imported data product. What does it look like? It's a service. It would be bad if it wasn't, because Daniel told you it's going to look like a service, but it's going to look like a service. We make it look like a service with some annotations, some magic around it. CDS external just tells us, well, it's an external service. This is the ORD ID that we use to then find it on the share, and some protocol annotation. Yes, it would be nice if this was all packaged, or at least these two, in a single annotation, but we're working on it, okay? In here, you have your entity supplier, because we are buying stuff. You buy stuff from people, and those people are usually sometimes called suppliers, because someone has to supply the stuff you buy. It's very big. As you can see, it's like 140 lines. I will have to search a bit. Is it in DB or is it in Surf? DB, yeah. We are also doing the same technique that Mark just showed. We strip it down to what we really want. We want a supplier, and the supplier should have a name. That makes it a bit easier to talk about them and not just use the ID, because IDs are not that handy. So how can you see that it's not connected yet? Okay, let's reload. That's looking better. Okay, let's see. Okay. In this value help, we see that we can buy products from Janine and Sebastian. This is the test data that we deployed with the CSV. You can probably buy the stuff that we sell from Janine and Sebastian. I mean, we sell reCAP stuff. It's more likely that we'll get it from Janine and Sebastian that you will get it from the suppliers we now have, but let's go to real suppliers from the S4 system. So this UI is something that we just built to make this demo run. In practice, your application will be configured to know which BDC to talk to via UCL integration. So this will all be done behind the scenes. And we are not quite sure who will do it in the end. Probably some clicks in the BDC UI will trigger the actual installation of the data product. For now, it's this UI. And there's a single data product that you can install, the supplier data product. This will take a bit, because what we are doing behind the scenes now is generating the virtual tables into synonym configs and triggering an HDI deployment. And now we can go and see what we have in here. Let's create. This should not take longer because this is still, okay. Here we go. As you can see, it's taking a bit longer. There's two reasons for that. A, it's a bit more data. And B, it's going to the remote system. Because now we have quite a few people we can buy stuff from. Quite a few people. I sometimes the same person multiple times, but hey. So we know that it works, but let's look at what happens on the database. We have quite a few synonyms in our container, or rather one in this case. Let's open it, and we can see that it is for a view. Why is it for a view? Because I lied to you in the beginning. We don't just generate virtual tables, but we also generate mapping views so that the names from on the virtual table side look like normal CAP names when you consume them in your application. Because, as you know, we uppercase the identifiers and just let HANA deal with it, but that's not what everybody does. If we now undo our data product installation, let's select it and kill it. Who needs this anyway? And refresh here. It should point. Why is it not pointing to the other one? Let's see. That's what you get for doing live demos. Value help, yeah, the value help is back. I'm not sure why the synonym is not back because the value help. Yeah, that's probably the easiest. Yeah, let's duplicate it. I thought that the refresh button would do it, but yeah, the refresh is a lie apparently. So let's see. Yeah, the database studio doesn't like me anymore, which is fine. No, we can now see that's for the dummy table. So the mechanism, the proof of concept of consuming the data products works. We've got that part running. How to integrate it in the bigger scheme of things and make it easy consumable is not your problem. It's our problem. We will take care of it. On your side, you will just do some CDS modeling. And the rest will be magic. Lots of magic and lots of fishes. Yeah. You don't want to remove them. They stay around. They stay around. Yeah, because the data product could be uninstalled in the future. And if the data product is uninstalled, then we need something to point the synonym back to. Yeah. I think we have time for questions now.
Yeah.
Do you have any?
First of all, a big round of applause for the speakers. All right, questions in the room? Yep.
That was now the consumer side of data products. Is there also a provider side for data products?
Yes, we are also working on the producer side, but it's a bit harder to show the producer side. On producer side, you will have to model a service because that's what you will serve your data product as. And then we do some magic. It's easier to call it magic. We call some APIs behind the scenes and trigger some replication. So the HANA will take care of replicating the data from your table into the data lake. You just take care to put it in your model and say, I'm serving a data product. And we do the stuff with UCL handshaking and BDC and who else is there. Yeah. Work in progress still, but not as good to demo, so we didn't.
We have another question back there.
Zeit reinholen kann ich gut.
So will it be a push replication using views, or will it be a table replication using redo docs?
I don't know enough about the HANA specifics. The word RLT has been mentioned quite a bit, and some schedule service will run. So I'm not sure if that seems more like a push because the HANA will push the data in, I guess.
Okay, thanks.
Yeah, but they are working on how this can be the most efficient way in the end.
Hello.
It's working on view level. Yeah.
The question is, how do you manage the authorization to the provider? I mean, the DB user, how is authorized to access data if you need a grant or file or something like that?
For production or consumption?
For both.
Okay, so for production, the user that actually reads the data and replicates it is created by the HANA. And we deploy a specific HDB role that has the rights needed and granted during tenant mapping. So when
And this is automatically
yes,
done?
this is done behind the scenes. So we get the call from UCL that, hey, you're now connected to BDC system. And then we trigger getting the HANA side set up so that they get the user, they give us some certificate magic. And this user gets then granted the role to actually access the table where we put the data in by us. Yeah.
Thank you.
And yeah, consumption side, similar granting mechanism. Consumption side is a bit different because there the BDC side grants us the rights. So you do UCL exchange of who you are, and then you get the rights granted to the HDLFS container. And with that, you're able to read it.
Right, that's it. We're out of time. Big round of applause again.